Welcome to Get Your FRQ On. This question is from the 2000 Calculus AB exam. It's question 2, and it is calculator active. In the question stem, we are provided with a graph representing the velocity of a runner A and a function representing the velocity of a runner B. In part A of the question, we are asked to determine the velocity of runner A at t equals 2 and the velocity of runner B at t equals 2. The velocity of runner A is given to us by a graph, so the velocity of runner A at t equals 2 would just be the y-coordinate on the graph at t equals 2. The slope of the line that makes up that portion of the graph of VA of t is 10/3 and contains the origin. Therefore, the velocity of runner A at t equals 2 is 20/3 meters per second. We just take the slope, multiply it by the x-coordinate 2, and we get 20/3. The velocity of runner B is given by a function, so we actually have to evaluate the function VB of 2 at 2. And if we plug that in, VB of 2 is 24 times 2 over 2 times 2 plus 3, and we get 48/7. So at t equals 2, the velocity of runner B is 48/7 meters per second. In part B, we are asked to find the acceleration of runner A at t equals 2 and the acceleration of runner B at t equals 2 and include the units. If we define the acceleration function little a, big A of t to be the derivative v prime a of t, and likewise for ab of t to be v prime b of t, we can determine the acceleration by differentiating the velocity functions for both runner A and runner B. Now for runner A, the velocity function is the graph. So the acceleration of runner A at t equals 2 would just be the slope of the graph at t equals 2. Checking the graph, we see that the slope at t equals 2 is 10/3. So the acceleration of runner A at t equals 2 is just 10/3 meters per second per second. To find the acceleration of runner B at t equals 2, we actually have to differentiate the function that gives us the velocity of runner B. So we need to find v prime b of 2. The function given is a rational function, so in order to differentiate, we will need the quotient rule. So if we apply the quotient rule at t equals 2, we can do the calculations and we get 72/49. So at t equals 2, the acceleration of runner B is 72/49 meters per second per second. This is a calculator active question, so you could also use a calculator to get this, but the function itself isn't difficult to differentiate, so you can do that by hand. Some calculator questions give you functions that you couldn't differentiate by hand or you couldn't integrate by hand or something like that, and so you need to use the calculator on those questions. This is not a question where the calculator is required, but it is available to you. In part C, we are asked to find the total distance run by each of runner A and runner B over the first 10 seconds. Since the velocity of runner A at time t is given by the graph, the total distance run by runner A for t from 0 to 10 is just the area bounded by the graph and the x-axis between 0 and 10. The graph for the velocity of runner A is given by two line segments. So if we integrate VA of t from 0 to 10, we can calculate that integral just by doing a little bit of geometry formulas for area, and we get 15 plus 70, which is going to be 85 meters. So in the first 10 seconds, runner A ran 85 meters. Likewise, since the velocity of runner B is given by the function, we need to find the total distance run by runner B by integrating that function from 0 to t equals 10. So we're going to have to integrate VB of t from 0 to 10. This is a calculator active question, so I would recommend doing this using a calculator. You may find it very difficult to do otherwise, but make sure you indicate what calculus you're asking your calculator to do, so you should at least have one of these two functions written down in your response. And then using your calculator to actually come up with the integral, we get about 83.336 meters.